Welcome back to our series of solution and explanation to competitive coding. Today we are going to solve LeetCode question number 94, binary tree in order traversal. So let us understand the question first. Given the root of the binary tree, return the in-order traversal of its node value. So we are given the root of some binary tree, and we have to return its in-order traversal values. We have to do in-order traversal. So we'll understand what in-order traversal is. It is basically left, then root, then right. This is in order. We'll understand that, but first we understand how node of a tree works. So here they give the explanation of a node of a. It has some int value, that is the value that that node holds, and tree node left, that is it holds the reference to other node, which is left child of a tree, because this is a binary tree. So it has like left child and right child, so tree node left and tree node right, and whatever value you pass as the value, this dot val will become the value, that is this reference. This refers to value which is in the node of the tree. Okay, and if you pass the left or right child, it will give assign those references to left and right nodes of this tree. Now we understood the structure of a node in a binary tree. Let us understand what in-order traversal is and some other data structures that would help us to solve the question. So what in-order traversal, how we write algorithm is that first we check if the current node is empty or null. If it is not, then we traverse the left subtree by recursively calling in-order function and display the data part of the root or current node. We recursively call in-order function until we find null or empty node. Okay, that doesn't have any data. Okay, that's value part is null. Okay, display the data part of the root or current node, traverse the right subtree by recursively calling. So how in-order function works, as I already told, here I've also written left, then root, then right. That is, we'll first go for left part, then root part, then right part. Here is solution for a simple tree. If this is the tree, how it will work. It will go for left, again we have left, we will go for left, we'll print this data, then we'll go for root, then we'll go for right, print this data, go for right, but we have left, we will go for left, then root, then right, and so on. Okay, so let us solve this particular tree to understand it more in more better way. So suppose we have given this tree, so how will we traverse it? We'll go for this part, that is root. We are given root, so we'll push it into the stack. Oh, okay, let me explain a stack and ArrayList a bit. So a stack is the data structure that follows LIFO, that is last in first out, LIFO. Whatever element is embedded or inputted in last will be fetched out or popped out first. Okay, so stack follows this property, that is we go on pushing elements into the stack. We'll push some element, but when we pop out, it will be the last element. It's work like a bucket. Like if in the bucket we put some plates, so which plate we put the last, we have to fetch out that plate at first. We can't go and dig under the stack and pull the first plate what we have put. So it works basically on the principle of LIFO, that is what element is put last in the stack will be popped out first. Okay, and what ArrayList is, it is basically a dynamic array. It's simply array which contains similar type of values, but it is dynamic. How it is dynamic? In the memory sense, like it will automatically grow when it is about to fill. When we are lacking of memory, or when we need to add some extra elements but it is already full, it will allocate extra space to us. It will dynamically grow its size. We don't have to care about its size, so we are using this. We will use this data structure to put our elements, because we initially don't know the number of nodes in the data structure. That is, we are using ArrayList, not an array. So simple. It has dynamic memory allocation. Okay, so a stack has like dynamic memory allocation. Good. Now we are starting from here. So we have 1 as our root. We'll push it as in our stack. So now our 1 will be here, and okay, we will go for left. We'll call for left child. Then our 2 will become where is it? Okay, now we will go for the left child, and we have to go for next element, that is 2. So our next element would be 2 because it is our left child, and then again we have an element in the left, so we go for that, and we'll push 4 into our stack. Simple. It's like this. Okay, so 4 will be our next element. But now when we go for the next element, for the left part of that element, we'll find the null or empty. So we won't add this one, and we'll return to our root. That is, we'll pop out, we'll make our current element our last element we added in the stack. So this one will become our new element. Its current part is this, and we will move this. That is, we will pop this 4 from here. We will pop this 4 from here, and we'll pop out the 4 from here and put its value in our dynamic array. So in order to so that we can we have traversed the left part, we have finished with the left part. Now left is done, then we could move for root, then we'll have to go for right. So we are done with left. Now we are moving to root, and we'll put this into our array, dynamic array what we have created. So 4 will now become, 4 will come here, and we will remove 4 from here. So now if we are done with here the left part and root, now we have to move for right. Now we will go for right. Again we find the null. Now nothing is left. Now we'll make our next element on the top of the stack. Because for this we are done with left. Now 2 will be the next element, and we will push it value, pop its value from our stack, and we'll put it in our array list. Now next element would be our 2, and now we'll go for its right, because we are done with root, and we are done with left part, root part. Now we have to go for right, and we push this element into our stack. Okay, so our next element in the stack would be 5, and we'll go for its left and its right, and we find both. If it's left, it is null. We'll pop out this element, and we'll put in our array list, whatever we have created, and now we'll go for its right. There is null, so we don't have anything. Now we are done with left part for this one. Now we'll pop this element out from our stack. Okay, we'll pop this element out from our stack, and we'll put it in our array, and we'll go for right of it. Okay, now we are done with left part, root, and we are moving to right. Right there is again we find element, we'll push it in our stack, and 3 will be our next element in the stack, and go for left, null. Again our 3 will be popped out, and put it in our array list, and go for right part. Okay, now again go for right. Again 6 is our new element of stack. Now go for this one, left, check left, empty, pop this out, put it in our array, and check for right. Now right is again empty, and we are done, because we are nothing left in our stack to pop out. Okay, so this would be our Inorder Traversal. Now let's code and check whether it works or not. So first what we have to do, we have to make 2 stacks and array list what we have. So it has data structure stack of in the stack we are storing 3 nodes, TRENOD, 3 nodes, a stack of 3 nodes, and suppose we call this as tsk stack equals new stack. Okay, so we have created our stack. Now we are going to create our array list. So list of integers, because we have to store the value integers. Suppose this is our result, res equals new ArrayList dynamic for dynamic allocation. We are done with our stack and now we will check if root is empty because here constraints are given. Yeah, number of nodes could be like 0 to 100, so it could be like 0, so we have to check whether our tree is empty or not. So if root equals null, oh sorry, there isn't anything in root, so we have to just simply return, or we could do it like return result, return result. We have nothing in our array list, we can return simply that. But if it is not, then we have to do something like a tree. We have traverse, something like that. Tree node. Suppose some tree node is like current equals root. We are given root. Okay, so our new current element is root element. Now current value is root, and we have to check while either current is not empty, that is current is not null. See, current is not equals null, or not stack is empty. Stack is like stack dot is it check whether stack is empty or not, that is whether there. So if any of those is true, loop will continue, and again we have to traverse for left part, so we will do while current not equals null. So we will recursively call our left part, that is we'll first put our root in stack, that is stack dot push current, and go for left, current equals your current dot left. Okay, current will become current dot left, so we'll recursively do that while our current isn't left, and when it is left we have to do current equals, if like we are on the last element, current is our last element, we can see here, yeah, pictorially. Yeah, suppose we are here, yeah, we are here, now our current is our last element. So what we have to do is, okay, now we are on this part, current is empty, so we have to pop and make this one current equals, okay, stack dot pop function will work here, I hope so. Yeah, current will be, and we have to put its data into our array, like result is result dot add current dot val, yeah, current dot val part. Okay, so it will add our current value, and we will go for right part, that is current equals current dot right. Okay, so I hope it will work, and at the end we have to return our result array. Yeah, let's run a code, check if it works or not. Oh, some errors, list integer. What is the integer? So it is integer, not integers. Okay, and now we can move right here. Yeah, let's check if other bugs are there. No bugs found. Good. Now let's submit our code. It works, I don't know, but it is pretty much slower. So this was it. Hopefully you have a better solution. If you have, so please let me know in the comments. Thanks for watching.